Welcome to the quiz review for day 108. Let's jump right in since you've got a quiz in about 20 minutes. Okay, the two skills we're going to practice are graphing growth and decay functions and then solving exponential equations. Today you'll be allowed to use your notebooks for your quiz. So one of the questions that you'll see looks something like this. It says, if the function f of x equals 3 to the power of x is graphed, which x value would give you a point closest to the x-axis? So it's saying if I were to graph this function, which of these x values will get me closest to the x-axis? Let's actually graph it. It says if it's graphed, well then you need to graph it. So 3 to the power of x is an exponential function. Your question is this growth or decay? Is it regular or flipped? And what's my horizontal asymptote? So this would be growth. For growth or decay, you always look at the base of the exponent. Okay, if I had a number like this, I would only look at the number 3. That's the base of the exponent. Since it's greater than 1, it's going to be growth. However, if I had something like this, now my base is less than 1. So then I would be graphing a decay function for this. This one would be a growth. You always look at the base. If it's less than 1, decay. Greater than 1, growth. Next, we're going to actually graph it, okay? This is regular because there's no minus sign out in the front. So we'll graph it, and my horizontal asymptote is 0. So it says, which x value? 1/5, that's about approximately over there. -1, that's like over there. 5, or 0. Which x value brings your graph closest to the x-axis? So clearly from looking at this, the further to the left I go, or as x gets smaller and smaller towards negative infinity, that's when my graph is getting closer and closer to my x-axis. So my answer here is -1. So for these questions, you actually have to graph it to visualize what's happening. Let's try 2 more problems. You try first now. So if I had 3 to the negative x. So in this problem, we're going to look at the base to determine if it's growth or decay. Since my base is 3, I would say growth if I didn't know any better because, hey, your exponent is negative. What do negative exponents do? They mean take the reciprocal of the base. This is really 1 over x. 3 to the negative 2 is really 1 over 3 squared, for example. So over here, when you see a negative in the exponent, you actually have to rewrite this. That's f of x equals 1 over 3 to the power of x. So now having a look at our base is less than 1. That means I am decay. So now from these 4 numbers, which one brings me closest to the x-axis? Well, that would be the further to the right I go, the closer to the x-axis that I get. So the answer would be 5. In our last example here, you have to again graph this. Is this growth or is this decay? Looking at our base, this is less than 1. That means I'm decay. So again, the closest to my x-axis, see this guy on the left at like -10, let's say, is really far from the x-axis. At 0, I'm getting closer to the x-axis. But the bigger and the more positive I get, then my answer would be 5 again. Okay, so when x is 5, I'm closest to the x-axis. All right, next question we're going to practice. Solving for x in an exponential equation. So I have the steps written out over here on the right. Step 1, find a common base. So look at the numbers you're dealt with on the left and on the right. 16 and 8 can both be rewritten as powers of not 8, not 4, because 4 squared is 16, but you can't write 8 as a power of 4. But 2 would work. So I'm going to rewrite this guy. No, I'm going to put him in parentheses right away. And I'm going to put him in parentheses right away. I'm going to write them both as powers of 2. So on the left, I'll have 2 to the 4th to the power of x plus 1. You have to put parentheses when you're rewriting. And on the right, I'll have 1 over 8 can be written as 2 cubed to the power of x. Okay, next step, we're going to distribute. We're going to use our rules of exponents. which means if I have a power to a power, you multiply. So on the left, I'll have 2 to the 4x plus 4, because you have to distribute the 4. And on the right, I'll have 1 over 2 to the 3x. My next step is to get rid of fractions. So that means over here on the right side, it would be incorrect. Please, 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 do not cross out your bases yet. You have to get rid of the fraction. You have to use negative exponents to get rid of that fraction. So my left side is good to stay 2 to the 4x plus 4, but on the right side, I'm going to multiply my exponent by negative 1. Multiply it by negative 1 to get out of the denominator. So it'd be 2 to the negative 3x. Now that I have common bases, I can cross them out and set my exponents equal to each other. So 4x plus 4 equals negative 3x. I'll move the 3x, I'll minus 4x on both sides. So this part's just algebra. I get 4 equals negative 7x, and x equals, divided by negative 7, negative 4 over 7. Okay. The steps leading up to here are the most important. So let's see if you can do these ones yourself. Pause the video and see if you can give it a shot. All right, so the solutions to these, my common base on the left and the right would be 9. I can write 81 and 9 as factors of, powers of 9. So on the left, I'll have 9 squared times 3x plus 2. And on the right, I'll just leave it. My next step, distribute. So I have 9 to the power of 6x plus 4. And on the right side, I'm getting rid of my fraction, 9 to the negative x. Now that I truly have common bases with no fraction anymore, cross these out, set my exponents equal. I can minus 6x on both sides. 4 equals negative 7x. This is so funny. Did we get the same answer? Oh, that's so funny. So x equals negative 4 over 7 again. On the right side over here, we'll write these both as base 3. So on the left side, it stays. On the right side, 81 is 3 to the power of 4. There are no fractions to get rid of, so right away you can cross these out. Add the 5 to the other side. X equals 9. Now if I gave you the problem, like this was the question that you were given right away, with the bases already the same, that's the easiest sort of problem. Just cross them out right away if there are no fractions and set your exponents equal. All right, next skill. We'll talk about graphing one more time. So it says, hey, graph this function. So what we notice now is that I have a number in front. That's like our multiplier. This is our base. This is the most important number. And we have our exponent. So the question is growth or decay. So we're looking at our base here. Don't be distracted by that 1/2 out in front. This would be a growth function because my base is greater than 1. Since there's no negative up here, it doesn't flip. I would not rewrite this as 1/3 to the x. It doesn't become decay because my exponent is regular. Now it's regular because there's no minus out in the front. And my horizontal asymptote's at y equals 0. So let's graph this. Growth, regular. So remember, growth looks like this, low to high. Decay goes the exact opposite way. So this one's growth. And this is the shape of decay. They're always graphed above the asymptote, no matter what, okay? All right, so let's graph this. It's growth, it's regular, horizontal asymptote is at y equals 0. So the question says, what's the y-intercept? Please make a note to yourself. For the y-intercept, you need to set x equal to 0. So we actually have to show some work. So my y-intercept is going to be y equals, or f of x equals, 1/2 times 3 to the power of 0. So you'll always do this part first. And since we're setting x equal to 0, anything to the 0 power is 1. So I have y equals 1/2 times 1, which is just 1/2. So my y-intercept is always 0 in the x spot because we set x equal to 0. And then whatever you end up with after doing the math. Hint, it's always going to be this number if this guy always becomes 1. Right? 1 times that number is just 1/2. Now the exponential factor, that's just a fancy way of saying the base. and our base is 3. But pay attention. If it had been 3 to the negative x, my base is not 3. My base would have to be 1/3. You'd have to flip, take the reciprocal. Okay, my domain for these is always, look at the arrows, negative infinity to positive infinity. And now my range, that's reading from bottom to top. Well, my graph doesn't exist down here, but it begins at 0 and it goes up until infinity. But notice it doesn't actually hit 0. That's where our horizontal asymptote lies, right? So it's from 0 to infinity, not including 0. All right, 2 more quick ones. You try now. So your job is to graph it. Pause the video, see if you can do it. So looking at the base, this is dk. Okay. My y-intercept, setting x equal to 0, I'd get y equals 3 times 1/2 to the 0. That gives me 3 times 1, which is 3. So my y-intercept would be 0, 3. It's a point. It's right here, 0, 3. My exponential factor, that's just my base, which is 1/2. My domain, as before, is negative infinity to infinity, and my range from bottom to top is from 0 till infinity again, because I only exist for these positive y values. Last example. Okay, growth or decay. Hey, hold on, negative exponent means rewrite. You have to rewrite it. So it's 0.6 times not 5, but 1/5 to the x. So this is actually decay. Horizontal asymptote y equals 0 also. So our y-intercept, setting x equal to 0, is 0.6 times 1, because 1/5 to 0 is 1. So it's 0, 1/6. My exponential factor, if you weren't being careful earlier, you would have said 5, but my exponential factor is actually 1/5. My domain is still negative infinity to infinity from left to right, and my range is still from 0 to infinity, bottom to top. All right, last problem. So now I just want to show you, here we have a decay function. My base is less than 1. So I'm going to go ahead and graph that first. It'll look like this. So assuming that that's our basic graph of f of x, let's see if you can determine what all of these other functions look like. They're just transformations. So for this one, since my plus 3 is big and hanging off the end, that's my horizontal asymptote. That means this has been shifted up 3 units. So the graph of g of x would actually look like this. It'd be 3 units higher everywhere because my new horizontal asymptote, that's my g of x, has a horizontal asymptote y equals 3. So if you can recognize that this outside number shifts you up and down, then you'll be fine. Next, let's look at h of x. Now I have a plus 3, but it's small and it's inside my exponent. That means it's being shifted the opposite way it seems. It's actually being shifted to the left 3 units. So my horizontal asymptote, notice, is still y equals 0 because there's no number hanging off the end. But it's been shifted to the left 3 units. So h of x graph actually looks like this. It still has the same horizontal asymptote. It's just more to the left than before. Whereas this plus 3 hanging off the end is up. Okay, final question, j of x. I'll do it in green. So now j of x has a negative exponent. Negative exponents mean rewrite, flip the base. So instead of 1/4 to the negative x, this is 4 to the x. Well, that just makes it a growth curve, actually, because my base is now greater than 1. So whatever you had before, we are now graphing the opposite. Horizontal asymptote is still nothing hanging off the end. It's still y equals 0. So if you can recognize matching each of these, then you'll be great for today's quiz. All right, I hope that was helpful for you. I'll see you later today. Good luck.